this afternoon. So let's look at the question together. The charge of magnitude 1.6 times 10 raised to minus 19 coulomb, that's quantity of charge, 1.6 times 10 raised to minus 19 coulomb, is placed in a uniform electric field of intensity 1200 volts per meter. That means the electric field intensity is 1200 volts per meter. Electric field intensity can be in volts per meter. It can also be in Newton per coulomb. The question now says calculate its acceleration. We have to find A. That's the acceleration. If the mass of the charge is 9.1 times 10 raised to minus 31 kg, the mass of the charge, that's mass of an electron, 9.1 times 10 raised to minus 31 kg. So don't forget, we have the quantity of charge, we have the electric field intensity, we have to find the acceleration of the charge or the electron. Then we have the mass, which is 9.1 times 10 raised to minus 31 kg. Now, if you want to deal with this now, the first thing to calculate is the force. That's the electric force. And electric field intensity is force over quantity of charge. That means if I make the force the subject of the formula, that would be electric field intensity times quantity of charge. Our electric field intensity is 1200 times the quantity of charge, which is 1.6 times 10 raised to minus 19. Don't forget, from definition of electric field intensity at a point in an electric field, that's the force acting per unit charge in that field, and that's F over Q. So I want to find the electric force first, which is electric field intensity times quantity of charge. And our electric field intensity is 1200 times the quantity of charge, 1.6 times 10 raised to minus 19 coulomb. So if I put this in standard form, 1, 2, 3, that's 1.2 times 10 raised to power 3 multiplied by 1.6 times 10 raised to minus 19. So I'm going to multiply 1.2 and 1.6. If I multiply 1.2 and 1.6, 1.2 times 1.6, I have 1.92. That's 1.92 times, then I will use indices for this. 10 raised to power 3 times 10 raised to minus 19. You know, if I'm using multiplication law of the indices now, this one will be 10 raised to power 3 minus 19. That would be 1.92 times 10 raised to minus 16 Newton. That's the force. But the question says we should find acceleration. We are now going to use Newton's second law of motion, or some people call it relationship between force, mass, and acceleration of a body. That's F is equals to ma. F is the force, m is the mass, a is the acceleration. So if I want to get my acceleration now, it will now be the force, which is the electric force, over the mass. Don't forget, we make a the subject of the formula here. You divide both sides by m. And when you divide both sides by m, you're going to have A equals to F over m. Don't forget, we've calculated the electric force, which is 1.92 times 10 raised to minus 16 over the mass, 9.1 times 10 raised to minus 31. So I will divide 1.92 by 9.1, then I will use indices for this. So 1.92 now divided by 9.1, I have 0.21. To 3 decimal places is 0.211. To 3 decimal places, 0.211. That's dividing 1.92 by 9.1. Then I'm going to use indices for this. You know, when 10 raised to minus 31 come up, using the negative index law of indices, it will become plus. So this one will be times 10 raised to power minus 16 plus 31. So that will give me, let me first write it here. My A will now be 0.211 times, when minus 31 comes up, it becomes plus, so minus 16 plus 31. I'm going to have 10 raised to power 15. Now, putting it in standard form, I will use one of the 10 to move this point forward. That will be 2.11 times. This one will reduce by 1. It will become 10 raised to power 14 because I have used one of the 10 to move the point forward in standard form. 2.11 times 10 raised to power 14 meter per second square. So that makes the correct answer to be A. 2.11 times 10 raised to power 14 meter per second square.